Hi, this is Paul. I'm at the Agilian plastic mold facility, and today we're going to be looking at the complexity of making injection mold tools. Let's have a look around the place. Hi, it's Paul and I'm back at the computer. So having a look around the injection mold shop, in particular the tool room, we can see there's quite a lot going on. Now in these slides, what we're going to be doing is walking through giving you an understanding of what the plastic injection mold tooling looks like from the DFM process all the way through to T1. Now T1/T2, this is trial 1 or trial 2 of the actual tools themselves. Okay, so let's dive in. So why is tooling so important and why does it matter? Well, it's critical for product quality, cost. It brings the cost down on mass production of various different components instead of machined components, and production speed is very quick to reproduce components from injection mold tools. It gives you high precision engineering with high tolerances on all the components you're looking for. And don't forget, errors in tooling do impact the part quality and the timeline. In other words, if you're making errors, you need to go through multiple iterations in order to get the tooling correct, in order to meet the tolerances required. And another thing that is often overlooked is the actual cost of tooling. This is a major investment upfront for any plastic injection mold process. Okay, so let's have a look at the timing of what an injection mold tool goes through. And we're going to go into a little bit more detail as we move forward. But in essence, we start off with the design, and then we need to purchase all of the components that go into the tool itself. And then once we've got the steel in, we then go through a machining process. I'm going to touch on some of the machines that are used in order to create the tools, and then we can see how many steps there are potentially. Once everything's machined up and ready to be put together, we assemble the tool in one place. We are then ready to put the actual injection mold tool into an injection mold machine. Now, this is generally known as T0, and again, I'm going to go through in more detail later on, but this is the first trial of the tool itself. Once we've made a few adjustments and sort of fine-tuning of various different aspects, whether that be steel or cavities or tooling or gate positions, whatever, we then go into the first formal trial, which is generally known as T1, or the first trial run of the injection mold tool. And then we can go on to trial 2, which is generally where we aim for final sign-off. Once it's signed off, then we can move into mass production. Okay, right, so let's dive into a little bit more detail with respect to the planning and the process itself. So, the tool design. It's not just the design itself. We look at the actual parts and we look at the DFM, or design for manufacturer, making sure the plastic parts have been designed correctly from a best practice point of view. We're looking at rib sections, rib thicknesses versus the wall that they are attached to with respect to the ratio that they'll be designed to, making sure there's no sharp corners in any of the mating faces. We are looking at a number of different aspects. Is the draft angles correct, or are they large enough in order to make sure that any texturing on the actual part doesn't get scuffed as it's coming out of the tool, for example. Once everything's done there from a DFM point of view, generally we will run a mold flow analysis. Now this is required in particularly on complex or larger cores and cavities. to ensure the polymer actually fills the core and cavity to its fullest extent. It will also show us where we've got some issues with respect to hot spots or burning or potential weld lines where the two melt fronts come together on the molten polymer. Then we are looking at the core and cavity, the cooling and the injection and all of the fine elements that go into making the tool itself. Once that's complete, now that will go through a review and get signed off. Once that's been signed off, we then need to go and order all of the components. Now we're looking at the mold base itself, which is the bolster set. And then we're looking at the core and cavity, which is where the money really lies, because this is where the detail is actually machined into the steel itself and hand finished and polished and make sure everything's meeting that criteria from a tolerance and specification point of view. Now, from a machining and fabrication point of view, there are a number of different machines or pieces of equipment that are used in order to shape the steel itself. Now, we start off generally with the CNC machining, where we're rough shaping out the actual parts themselves, and this includes the cores and cavities. Then they'll go on to an EDM or sparkle rotor machine, and then we've got grinding, and finally we've got hand polishing. Once everything's finished there and we're down to pretty much where we want to be from a tolerance point of view, we then go into heat treatment and hardening of all of the steels themselves to make sure that they're going to last the lifetime of the product run. In other words, various different steels can withstand a number of different quantity of shots. The harder the steel, generally the longer the life. We're talking over 1 million shots per some of these steels for the tool. So once everything's machined up, we then need to go into hand assembly and fitting. So we need to fit the cores or the cavities into the bolsters. We need to make sure the sliders are working, all of the lifters are functioning correctly, all of the ejector pins are pushing out correctly in all of the correct places. We're also checking the alignment and the functionality at this stage, generally on the bench. I've got a few videos and I'm going to insert them just here, just so you can have a look at some hand polishing and finishing. So what's going on here is the guy's putting on some marker or engineering red or engineering ink, whatever it is. So basically, as this part is assembled to this part, it'll be put down, and any touching points will be showing up red on here. In other words, any high points in the steel will show up on here, and then it needs to be hand finished or polished again, such that we get an even surface. So ultimately, what we're looking for is this whole surface to be completely red with no marks, with no gaps in the marking. So that's the idea of what all this red ink is about. Now the next stage we're looking at is, like I said, the T0. This is not a real trial run of any product itself. The initial T0 or first trial, which is generally classed as a T0, is just to make sure that the tool itself is functioning correctly. In other words, it opens, it shuts, all of the ejectors are moving nice and smoothly, nothing's sticking in place. Yes, we will run some plastic or polymer through the actual tools themselves just to make sure that they are ejected out, and making sure that all of the steel is functioning and the tools are working correctly. Once we've got some fine tuning done there, and this is where the sort of the parameters of the injection mold machine will be fine tuned as well. We then go on to T1. Now T1 is where you will see your first parts coming out of the tool that will be any good for checking the tolerances. Okay, so basically what we're doing here is making sure the tool is producing the parts to specification. Again, caveat here, we don't normally add the cavity texture because there are occasions where we'll have to make some modifications still to the actual tool itself in order to bring the final product into tolerance or make some final adjustments where required. Once that's done, we then go into the texturing stage, which will be prior to T2. Now T2, we like to actually aim for final fine tuning and where we can produce parts out of the tool which can be approved, and that allows us to then sign off the tools and move into mass production. So in more detail, again, let's go into tool design. So tool design, like I mentioned, we do move into the DFM analysis to start with, and that generally creates a report. That report is then circulated for review and sign off, or comments and feedback with respect to any changes that are required. Now this works both ways. The DFM analysis and report can actually identify areas where the design needs to be changed, or if the designer sees an area where I think, you know what, this is an area that could be improved upon, i.e. the gate position. If there's anything critical around the split line, for example, they can actually feed back into the tool designer. So that's a two-way street from respect to reviewing the DFM analysis and report. Once that's completed, the 3D mold design starts. That includes all of the placement of the ejector pins, all of the cooling and the runners, and either the hot runner or the cold runner system is all designed in. Then that goes again for another review. That review is then reviewed and fed back or signed off. Generally, we look for a sign off on the tool to make sure everything's okay from that point of view. And again, we're looking at runner positions, gate positions, gate styles, depending on the product complexity and how it's been used. A different gate could be required. But in general, this is where we're looking for everything to be signed off. If sign off is okay on the design review, we will then go into the bill of materials for the actual tool itself and the 2D drawings to be released. Now, the 2D drawings are required in order to cut the steel. But before we cut any steel, we're looking at material procurement. Now, we're looking at different types of steel for different parts of the tool. The cavity and the core, or the core and cavity steel, whatever the way you want to say it, is basically where the money is, because this is where all of the detail goes into the actual tool itself. The rest of the steel around the core and cavity is generally tough, hard-wearing, hard-lasting steel. And this is basically known as the mold base or the bolster set, which holds the core and cavity in place. Okay, so we're also looking at purchasing all of the other parts. We're looking at springs, ejector pins, ejectors, and everything that goes into making all of the heaters, everything that goes into making the tool up itself. And don't forget, we've already released the 2D drawings and the bill of materials to the purchasing team in order to get all of this in. Now remember, some supply chain delays can impact this phase if there's any specialty steels required, if there's any specialty other components or long lead items, or if suppliers out of stock, for example. This could impact this actual purchasing phase itself. But what we do encourage and what we try and do ourselves is look at standard components versus custom components, where custom components clearly do attract a longer lead time. So, core and cavity machining and fabrication next. This is where we're really looking at the different processes in order to actually machine out the shape of the component into the steel itself. Now, that would include CNC machining, EMD, which is spark eroding, polishing, wire cutting, It also includes matching the sliders and cores and assembly, hand polishing, grinding, and it just does require a complexity and a lot of skill based to actually get these parts finished and assembled together. Now, this is where most of the time is consumed when we are producing injection mold tools. And again, I've got a video of some machining and hand polishing, and I'm going to insert that here. Once all of that is finished, we're basically looking for checking the tolerances, make sure everything's okay before we do the assembly and the fitting. Now, on the assembly and fitting, we're looking at mating the mold components. We're installing everything together. We're putting the injectors, the cooling channels, the heating channels, and we're looking at making sure that the tool actually goes together, moves as it should. In other words, we're looking for a pre-trial debug session. Before we get onto the all-important T0 mold trial. Now, the T0 mold trial, like I said, is not really a trial where we're going to be producing any components. What this is generally doing is making sure that the tool runs correctly. And that is basically what this T0 is all about. We're looking for functionality of the mold tool itself. Now, what we can do is make some final adjustments, fine tuning. We are looking at optimization of the sort of the mold machine as well, and we're seeing how everything performs. Don't forget, we've already done a mold flow analysis, and this is our time to actually see the actual tool produce the first set of components from the chosen polymer. If everything's working out okay, we should see exactly what that mold flow result gave us. In other words, where the weld lines are, where the cold fronts, hot fronts, where there's any short shots showing or anything like this. So this is basically why this is really important, because it allows us to actually see any major defects before we move forward into the first trial. This allows us to give the time and effort to actually fix anything that is causing us issues. T1, this is where the customer will see the first set of polymer parts or plastic parts coming out of the steel tools themselves. Now, bearing in mind we've gone through a long process in order to get to this stage. And what we're looking for here is mold trials that will produce components that will initially be inspected to see if everything is within tolerance and within specification. If it's not, now we have the opportunity to make those fine adjustments before we move into mass production. And again, this is where it really matters, because we're looking at minor adjustments on the gate size. I've already mentioned that. That could be really, really important for some components. We're looking at cooling systems. Do we need to make it cooler, warmer, faster, colder, etc.? And looking at all of the ejection points, making sure all the ejection points are clear of all of the critical areas within the molded part itself. So once everything's there, we've done the fine tuning, and then hopefully we're into the last of the trials, which will be T2. Now, T2 is hopefully where we look at signing off or verifying the tool before we get to mass production. Now, all of the major issues should have been sort of completed that were identified in T1. The process parameters are fine-tuned for consistency before we move into mass production. In other words, they're written down on a record sheet or in a database, such that when we come back to this particular tool and polymer, we know exactly what the machine parameters are, we could just replicate those and get straight into mass production straight away. If there are any minor adjustments required, then these could be sort of done during this trial itself, but we're not looking at any major improvements, just very, very minor improvements, if anything. But the idea here is to actually get signed off and move into mass production. However, there are occasions where things pop up and think, you know what, I do need a bit of a major change to the tool, or a suite of tool, or another tool that the part matches to this particular tool, and therefore we'll have to go into the T3 or T3 or T4 as needed. But hopefully not. Hopefully the T2 will be able to get that signed off and move forward. So just have a quick summary. On the mold trials, we are looking at T0, which is the basic validation, and this is where all of the major changes get done. T1 is the refinements. This is where minor adjustments are carried out and all of the parameters are set on the injection mold machine. And T2 is where we're looking for final improvement or some very minor tweaks if required. So the final takeaways of the complexity and timelines as we're walking through the injection mold tool process is that plastic injection mold tooling is complex and time-intensive process. It's really important that you collaborate with your tool maker or tooling vendor to ensure that communication is clear, is fluid, you understand the process, you understand what you are asking for and what you are getting from your tool maker. Okay, so you need to make sure that you are included in the loops with respect to all of these reviews. Remember, I said at the beginning, a lot of the design reviews, you need to be in that loop. So you need a close collaboration with your tool maker. And always, always, always build in a buffer for the unseen delays, i.e. we were talking about delays to start with in the procurement phase, and you will see delays as we come through the tweaks in between T1 and T2. If you get to T3 and T4, then clearly you need that buffer to sort of carry you over from your project timeline aspect. So I hope that was a quick rundown and gave you some little bit of education and insight with respect to the complexity of what goes into injection mold tool. Thanks a lot, and I'll see you on the next video. My name's Paul.